Okay, so forget everything you think you know about moons. We're about to take a trip out to the Jupiter system, to a world that just completely breaks all the rules. This is Io. And trust me, it's a place of wild geological paradoxes, where the ground itself is caught in this constant, epic battle between fire and ice, forging landscapes that look like nothing else in our entire solar system. Just to give you an idea of how alien this place really is, let's talk about its mountains. We're not talking about mountain ranges like we have on Earth. Nope. We're talking about these colossal, totally isolated peaks. This one right here, for example, towers almost 18 kilometers high. That is nearly double the height of Mount Everest. But here's the kicker. The mystery that's had planetary scientists scratching their heads for decades. Io has no tectonic plates. The very geological engine that builds mountains on our planet, it's just not there. So the big question is, how on earth does a mountain like this even exist? To solve this puzzle, we are going to take a journey through Io's absolutely extreme environment. We'll uncover the immense forces that are twisting this moon apart and see how its volcanoes are nothing like Earth's. Then we'll get to the good part, the bizarre process that builds these impossible mountains. We'll even compare Io to its famous neighbor, Europa, and find out why this place is one of the solar system's most overlooked wonders.
All right, first things first. Let's get a feel for the landscape. Because Io isn't just a quiet, cratered moon. It's a dynamic, raging world of, you guessed it, fire and ice.
So get this, Io is the most volcanically active place we know of, period. Not just among moons, but in the entire solar system. At any given moment, you can find as many as 400 active volcanoes erupting, just spewing lava and gas all over its surface. This creates an environment of just incredible extremes. You've got these raging volcanic hotspots with active lava flows. But then, just a short distance away, the normal surface temperature plummets to a mind-numbingly frigid -130 degrees Celsius. It's a world of blistering heat sitting right next to absolute deep space cold. So you might be wondering, where is all this heat coming from? I mean, the sun is way too far away to do this. The answer lies in this invisible, relentless force that we're calling the Great Gravitational Squeeze. You see, Io is caught in a sort of cosmic tug-of-war. On one side, you have Jupiter's colossal gravity yanking it in. But on the other side, you've got the combined gravity of its sister moons, Europa, Ganymede, and Callisto, pulling it back out. This constant battle forces Io into an oval-shaped orbit, meaning it's always getting stretched and squeezed like a stress ball every 2 days. This process is called tidal bulging. All that stretching and squeezing generates a truly incredible amount of internal friction. It's kind of like if you bend a paperclip back and forth really fast. It gets hot, right? Well, for Io, that friction is the engine that literally melts its insides and powers hundreds of volcanoes. And the scale of this is just staggering. On Earth, our moon's gravity creates ocean tides of maybe half a meter. On Io, Jupiter's gravity is pulling on the moon's solid rock surface, creating a tide that rises and falls by as much as 100 meters. That's a tide of solid ground taller than a 30-story building. Just try to picture that. Now, this totally unique heating mechanism leads to a type of volcanism that is fundamentally different from anything we see on Earth. See, here on Earth, volcanoes build mountains. On Io, they often do the exact opposite. The crucial difference is this. Earth's volcanoes typically form where our tectonic plates crash into each other, forcing rock upwards to create those classic cone-shaped mountains. But Io doesn't have any plates. Instead, that constant gravitational stretching just rips open cracks and fissures in the crust, and the lava just pours right out from there. And those eruptions, they blast these enormous plumes of sulfur gas, hundreds of kilometers into space. As all this material snows back down, it paints the surface in this vibrant, almost psychedelic palette. That bright yellow you see, that's basically crystallized sulfur snow. The white and blue patches are frozen sulfur dioxide in the coldest spots, and those red areas are where sulfur is still being actively heated. So instead of building up, this process often causes the surface to just collapse. Molten rock then fills the void, creating these enormous lava lakes. The most famous one is called Loki Patera. It's this vast churning lake of molten rock that's over 200 kilometers wide. It's incredible. Okay, so if Io's brand of volcanism causes the surface to collapse, that brings us right back to our original paradox, doesn't it?
How in the world do you get those massive isolated mountains? And remember, we are not talking about little hills here. The tallest peaks on Io absolutely dwarf anything on Earth, soaring up to 18 kilometers high. But, unlike our mountains, they don't form in long ranges. They are just these lone wolves, stabbing straight up out of the plains.
So, are you ready for this? The way these mountains form is completely backwards. It all starts with those volcanic collapses we were just talking about. As a huge chunk of the surface falls in to create a lava lake, it generates immense downward pressure. All that pressure has to go somewhere, right? So it squeezes a nearby section of the crust, forcing it violently upwards. The result? A massive, steep mountain, born not over millions of years, but almost suddenly.
This quote from a scientist really nails how strange this is. It's a world where destruction in one spot directly causes construction right next door. A mountain literally born from a collapse. And this totally explains why the mountains are just randomly scattered all over the place. Gravity measurements from probes like Galileo confirmed that Io's magma isn't one big global ocean under the crust. Nope, it's trapped in these separate, localized pockets. Each pocket is basically its own little volcanic engine. So when a collapse happens over one of them, a mountain can just spring up nearby, totally independent of everything else. Now, to really appreciate just how unique Io is, it really helps to compare it to its famous sibling, Europa, which, by the way, is also heated by Jupiter's gravity. You've got these two worlds, both forged by the exact same gravitational force, yet they could not be more different. Io is a world of molten rock with the lowest known water content of any object in the solar system. It is bone dry. Europa, on the other hand, used that same tidal heat to melt its ice, creating a vast liquid water ocean hiding beneath its frozen shell. And that ocean, that's why we think Europa has a real shot at hosting life, while Io remains a sterile, if beautiful, volcanic inferno. And this fundamental difference, rock versus water, really explains why Io, despite its absolutely fascinating geology, has become something of an overlooked world in our current plans for space exploration. You see, in the next decade, NASA is sending the Europa Clipper mission specifically to search for signs of life in Europa's ocean. The European Space Agency is sending its JUICE probe to study the other icy moons. Both are going to be incredible missions for sure, but Io is the odd one out. There's no dedicated mission heading its way anytime soon. And that leaves us with this one tantalizing final thought. We've only just started to understand this impossible mountain building process. On a world so volcanically active that its surface is constantly being paved over and rebuilt, literally remaking itself every day, what other alien geology, what other bizarre, incredible secrets are just waiting to be discovered under that colorful, sulfurous snow?